In the last lecture, we have seen what is meant by double sampling plan. So double sampling plan basically is an extension over the single sampling plan. In single sampling plan, we take a decision about acceptance or rejection of a lot if we are talking about just the acceptance sampling plan. Then in single sampling plan, we take a decision about acceptance or rejection of lot on the basis of single sample. Whereas in double sampling plan, instead of taking a decision about acceptance or rejection on the only on single sample, sometimes a second sample is also used, and then we take a decision whether to accept or reject a lot, of course, on the basis of certain criteria. In double sampling plan, generally the decision of acceptance or rejection of lot is taken on the basis of two samples. Now, the situation is, if the first sample is bad, then the lot may be rejected on the first sample only, and a second sample need not be drawn. So we may not require second sample. If the first sample is very good, then lot may be accepted on the first sample only, and again, the second sample is not needed. So these are the two situations where we are taking a decision on the basis of single sample only, even though the plan is double sampling plan. In the first case, the sample is so bad that we are not going to accept the lot and we are going to reject a lot straight away without drawing a second sample. In the second situation, the first sample is so good that we are going to accept the lot on the first sample only and we are not going to draw the second sample. But if the first sample is neither good nor bad, right? So we are not able to term the sample as very good or very bad, and therefore there is a doubt about its result. And in such situation, we take a second sample, and the decision of acceptance or rejection of lot is taken then on the basis of information provided by the both the sample, that means the first as well as the second sample. Double sampling plan is defined by the four parameters. If you remember, in single sample plan there were two parameters. Similarly, here in double sampling plan we have four parameters. The first parameter is n1, that is size of the first sample. C1 is acceptance number of the first sample, n2 is size of the second sample, and C2 is nothing but acceptance number for both the samples combined. Now, how to do this basically double sampling plan? So this is basically the implementation. Suppose lot of same size, that is capital N, are received for the inspection from the supplier or manufacturer. The procedure for implementing the double sampling plan to arrive at a decision about the lot is described in the following steps. First, we draw a random sample, that is first sample of size n1 from the lot of size n. We will inspect each and every unit of the sample and then classify it as defective or non-defective, similar to our single sampling plan. Count the number of defective units found in the sample. Suppose the number of defective units found in the sample is D1. Then we will compare this number, that is D1, with our acceptance number for the first sample, that is C1. So if D1 is less than equal to C1, we will accept the lot. If D1 is greater than C2, then if it is acceptance sampling plan, we will reject the lot, and if it is rectifying sampling plan, then we will accept the lot after inspecting the entire lot and replacing all the defective units in the lot by non-defective units. Of course, that means we will send this particular lot when D1 is greater than C2 to rectification. But if C1 is less than D1 is less than equal to C2, then we will need a second random sample of size n2 from the remaining lot. So we will again inspect each and every unit of this second sample and again count the number of defective units found in it. That means we will inspect each and every unit of the second sample, classify it as defective and non-defective, and then count the number of defective units found in that particular sample, that is second sample. Suppose the number of defective units found in the second sample is D2. So in the first sample, we have number of defective unit as D1, and in the second sample, the number of defective units found are D2. So we will combine these two numbers, that means D1 and D2, and consider D1 plus D2 for taking the decision about the lot. Decision means either accepting the lot or rejecting or sending that particular lot for rectification. So this D1 plus D2 is now compared with the C2, which is nothing but acceptance number for both the samples combined together. So if D1 plus D2 is less than equal to C2, we will accept the lot and replace all the defective units found in the second sample by non-defective units. If D1 plus D2 is greater than C2, accept the lot. That means reject the lot or send the lot for rectification. In other words, that means accept the lot after inspecting the entire lot and replacing all defective units in the lot by non-defective unit. So that is basically shown using this particular diagram. Same thing is shown through this flow chart. I think I have discussed this particular diagram with you, this particular flow chart. Right? So for example, suppose a buyer purchases a cricket ball in a lots of 500 from a company. So lot size is 500. Now, to check the quality of the lot, the buyer and the company decide that the buyer will draw two samples of size 10. That means the size of the first sample is 10 as well as of two samples of size 10 and 20. That means the size of the first sample is 10 and size of the second sample is 20. Whereas acceptance number for the plan are 1 and 3. That means C1 is equal to 1 and C2 is equal to 3. So the buyer takes two samples and make a decision about accepting or rejecting a lot on the basis of two samples. Since the decision about acceptance or rejection of the lot is taken on the basis of two samples, this is known as double sampling plan. So the parameters of double sampling plan we know are N1, C1, N2, C2. So in this case, the size of the first sample is 10, therefore N1 equal to 10. The acceptance number is, in this case, C1 is equal to 1. Size of the second sample, that is N2, is equal to 20. And then the acceptance number for both the samples combined, that is C2, is equal to 3. So using this much of information, we can basically plan. So the buyer will draw a sample, first sample, that is N1 equal to 10, inspect each and every unit, classify it as, that means I'm talking about the cricket balls, classify it as defective and non-defective, compare that number of defective units with the C1 and will take a decision accordingly. Similarly, if the second sample is needed, again, he will count the number of defective units in the second sample, then combine both the number of defective units from the both the sample, of course, that means D1 and D2, and compare it with C2 and will take a decision accordingly on the basis of the particular comparison. So this is basically the double sampling plan. Now the different concept as far as double sampling plan, similar to single sampling plan, are operating characteristic, producer series, consumer series, and so on. So first we will see the operating characteristics. We know what is meant by operating characteristic. We have already seen that OC curve is an important aspect of an acceptance sampling plan. It basically gives us the power to check whether the lot is of good quality or bad quality, right? So that it shows the probability that a lot submitted with certain fraction defective will either be accepted or rejected. So that is basically the power I am talking about. OC curve can be constructed using the probabilities of accepting a lot corresponding to different quality levels. So depending upon the quality level, the lot will be accepted or rejected, and that can be basically seen through this curve also. In double sampling plan, the decision of acceptance or rejection of the lot is taken on the basis of two samples. We already seen that. The lot is accepted on the first sample if on the basis of first sample, if the number of defective units, that is D1, in the first sample is less than equal to, of course, less than equal to acceptance number, that is C1. The lot is accepted on the basis of second sample if the number of defective units, that is D1 plus D2 in both the sample, is greater than C1 and less than or equal to the acceptance number C2. So it should be less than equal to C2. In other words, lots will be accepted under the following mutually exclusive. These are the two situations where the lot is accepted, and operating characteristic, one aspect is probability of acceptance. So that's what we are trying to evaluate. So the first situation is that the number of defective units in the first sample, that means D1, is less than equal to C1. So 0 less than equal to D1 less than equal to C1. In this situation, we are going to accept the lot on the basis of first sample only. Suppose D1 is greater than C1, that means D1 can be C1 plus 1, D1 can be C1 plus 2, up to C2. That situation may be like this. Suppose D1 is equal to C1 plus 1. But D2 is such that D2 is less than equal to C2 minus C1 minus 1. So if you remember, we are going to accept a lot if you draw the second sample on the basis of condition that D1 plus D2 should be less than equal to C2. So that's what I have basically tried to separate. D1 here is equal to C1 plus 1 and D2 is less than equal to C2 minus C1 minus 1. So if you try to find out D1 plus D2, then that is nothing but D1 plus D2, and if you add right hand side also, then you will find that D1 plus D2 is less than equal to C2, right? So in such situation, again, we are going to accept the lot, even if we are drawing the second sample. So that situation can be generalized also. Suppose D1 is equal to C1 plus 2. Then in that case, D2 should be less than equal to C2 minus C1 minus 2. Then again, we are going to accept the lot. So this situation will continue till D1 equal to C2 itself. But D2, that means the number of defective units in the second sample are 0, and therefore we can again term that D1 plus D2 is equal to C2. And in such situation again, we have to accept the lot. So these are the situations where we are going to accept the lot, and all these situations are mutually exclusive. So in using this particular thing, then by addition theorem of probability, the probability of acceptance for a lot of incoming quality P is given by this summation. So if I am talking about only first sample, then number of defective X indicate the number of defectives. So X equal to 0 to C1. This is the situation where we are going to accept a lot on the basis of first sample only. And G of XP is nothing but the probability that X number of defective units are there in the sample. So that particular probability is nothing but summation X equal to 0 to C1 G of XP will give you that particular probability. But if X is greater than C1, that means I'm talking about this situation, X equal to C1 plus 1 up to C2, then in such situation we will need second sample. So for that particular thing, then we need the conditional probability. Now you can see here there are two functions. G of XP is nothing but your uh, the probability of finding X defective units in the sample, whereas H of Y such that P given X. It means that it is the conditional probability of finding Y defectives, since we are needing the second sample because X is above C1. So this is nothing but the conditional probability of finding Y defectives in the second sample under the condition that the X defective items have already found in the sample, right? So that is basically the information we will have if we draw the second sample, because X number of defectives are already obtained in the first sample, right? So that is basically the probability, that is probability of accepting a lot for incoming quality P, right? So thus we have G of XP, as I said, is nothing but probability of finding X defective units in the sample. We know that this follows binomial as hypergeometric distribution, and therefore we have this expression where NP are nothing but the number of defectives in the lot. This is nothing but number of defectives in the sample if I am talking about the first sample. Then Number of non-defective units in the lot are n minus np, and number of non-defectives in the first sample will be n1 minus x, where x are number of defectives, upon nc n1. So that means the lot size upon the lot size, and n1 is nothing but the size of the first sample. Whereas this is conditional probability of y given x, where x indicates the number of defective units in the first sample, y indicates the number of defective units in the second sample. So again, this will follow almost same distribution, but here we are having that particular information that number of units, number of defective units in the first sample are already obtained, and they are x. So the number of defective units in the lot, therefore remaining lot I am talking about is NP, which are nothing but the number of defective units in the whole lot minus X. I am talking about the second sample. So the number of defective units will be NP minus X, CY. Y is nothing but number of defective units in the second sample. Similarly, N minus N1, N1 already inspected. So N minus N1 minus, these are the number of non-defective units remaining in the lot, that is np minus x, c n2 minus y. That means the number of samples, sample size, second sample, size of the second sample, that is n2 minus y. Y is number of defective units, so non-defectives will be n2 minus y, divided by, these are nothing but the remaining units, n minus n1, c, n2. So this is basically that conditional probability. Using this much of information, we can now write down probability of acceptance, which is equal to, that expression we have already seen. We have just put those values, that is g of xp, here g of xp into h of y given x, and this is nothing but that probability, that a1 to indicate it is based on the single first sample. This is nothing but if the second sample is required. So this is nothing but probability of accepting a lot on the basis of first sample, and this is nothing but probability of accepting a lot on the basis of second sample. And the combine, that is by using addition theorem, this is nothing but probability of accepting a lot in the double sampling plan. So this is basically the operating characteristic of, that is OC curve, as far as double sampling plan is concerned. So as I said, PA1 and PA2 denote the probability of accepting a lot on the basis of first sample and second sample respectively. Now, let us see the expression for producer's risk as well as consumer's risk. Now, as far as producer's risk is concerned, we know the definition: probability of rejecting a lot of acceptance quality level. That means lot is of good quality, but it is rejected. So that is the risk the producer always faces. So that is nothing but the producer's risk. So the probability of rejecting a lot of acceptance quality level P bar is known as producer's risk. The producer's risk for a double sampling plan is given by the PP, P to indicate that it's about producer, and P bar is nothing but the acceptance quality level. So that is nothing but probability that rejecting a lot of acceptance quality level, that is P bar. In other words, that is equal to 1 minus probability that accepting a lot of acceptance quality level P bar. We already seen what is meant by, what is the expression for probability of acceptance. So we are going to use that particular expression. So using expression 1, by replacing P by P bar, that is acceptance quality, the producer's risk for double sampling plan is given by this. So you can see that instead of P now, we have here P bar. So this expression is nothing but the producer's risk. Similarly, consumer's risk can be also obtained. Now, consumer risk is nothing but the probability of accepting a lot of unsatisfactory quality. We know that LTPD, that is lot tolerance percent defective, that is PT, is known as is nothing but LTPD. And if the consumer have to accept such quality, then that the consumer's risk for double sampling plan is given by probability PC to indicate consumer, C indicate consumer, probability that accepting a lot quality of PT. So again, instead of P, we will replace it by the PT, and therefore the resultant expression is nothing but the consumer's risk. You can see here, instead of P, now we have here PT. So this particular expression is nothing but the consumer's risk. Then another important aspect as far as any sampling plan is concerned is average sample number. The average sample number is the expected number of sample units per lot which is required to arrive at a decision about the acceptance or rejection of the lot under the acceptance sampling plan. In acceptance double sampling plan, of course, I am talking about the number of units inspected to arrive at a decision of acceptance or rejection of a lot depends upon whether the decision is taken only on the basis of first sample or the second sample is required, right? So if the second sample is required, then the second sample size will be also considered. Therefore, there are two situations. If the decision is taken on the basis of first sample, and of course the size of the first sample is n1, then the number of units inspected is n1. However, the probability of taking a decision of acceptance or rejection of lot on the basis of first sample, suppose if it is P1, and the second situation is if the decision is taken on the basis of second sample also. That means we are not able to take a decision on the basis of first sample, and therefore second sample is drawn. The size of the second sample is suppose n2, then the total number of units inspected is n1 plus n2. Of course, the probability that second sample is necessary is 1 minus p1. Naturally, p1 is nothing but the probability that we have taken a decision on the basis of only one sample. So if we are needing a second sample, naturally its probability will be 1 minus p1. So therefore, the ASN for double sampling plan can be obtained as follows. ASN, as you know, average or expected number of units inspected per lot will be equal to summation that inspected number of units into probability of taking that particular decision, because it will depend upon that particular probability. Therefore, ASN will be equal to N1 into P1. As I said, P1 is nothing but probability of taking a decision either to accept or reject, but probability of taking a decision on the basis of single sample or first sample is P1, then N1 into P1, because in such situation we will only inspect N1 number of units. Second sample will not be needed because we are either going to accept the lot or we are going to reject the lot. The second situation, when we are not able to take a decision on the basis of first sample only, we will need second sample. So if we are not able to take a decision on the basis of first sample, then its probability is 1 minus P1. And in such situation, number of units inspected will be N1 plus N2. This is first sample, this is second sample. So in all, that is nothing but N1 plus N2 into 1 minus P1. So combining these two situations, we will get ASN equal to N1 plus N2 into 1 minus P1. That is nothing but your average sample number in the case of double sampling plan. Where P1, as I said, is the probability of making a decision about acceptance or rejection of the lot on the basis of first sample, and can be calculated as probability that lot is accepted on the first sample plus probability that lot is rejected on the first sample. Then one of the most important aspect as far as any inspection plan is average total inspection. So from producer's point, the total inspection should be less so that the cost is saved as well as time is also minimized. So one of the important feature of the rectifying sampling plan is the average total inspection. Under rectifying sampling plan, the rejected lots are 100% inspected. The ATI is defined as follows. The expected number of units expected per lot under the rectifying sampling plan is called average total inspection. So in the rectifying double sampling plan, the number of units to be inspected will depend on three situations given below. If the lot size n is accepted on the first sample of size n1, it means that if you draw the first sample and the lot is accepted, then the number of units inspected is n1, and the probability of accepting a lot on the basis of first sample is PA1, right? That is nothing but 1 to indicate the first sample, PA to indicate acceptance probability. We have already seen this particular probability, right? If the lot is accepted on the basis of second sample of size n2, the number of units inspected is n1 plus n2, and the probability of accepting the lot on the basis of second sample is PA2, right? So in both the situation, we are going to accept a lot. So the number of inspection in the first case is n1, whereas in the second case, the number of inspection is n1 plus n2, that is size of first sample and size of second sample. But if the lot is rejected on the basis of first or second sample, then the entire lot of size n is inspected, right? So if I'm talking about rectifying sampling plan, and if the lot is rejected, then each and every unit of the remaining lot is inspected, and the probability of rejecting the lot is 1 minus p. Therefore, ATI, that is average total inspection for the double sampling plan, is nothing but expected number of units inspected per lot, that is nothing but summation that inspected number of units into probability of taking a decision. So therefore, ATI will be equal to N1 into PA plus 1, A1 plus N1 plus N2 into PA2 plus N into 1 minus PA. So if you are taking a decision on the basis of first sample and you are accepting a lot, then that probability is nothing but PA1. In such situations, since you have inspected only the first sample, the total number of inspection will be N1. But if you are taking a decision on the basis of second sample and still you are accepting a lot, then its probability is nothing but PA2. But in this case, the number of inspection or total number of inspection is first sample plus second sample, because here we are inspecting each and every unit of the first sample and then the second sample, and therefore total number of inspection will be N1 plus N2 into PA2. Plus, if the lot is not accepted, in that case, the probability will be 1 minus PA, and in such situation, we will inspect each and every unit, and therefore N into 1 minus PA will be the total number of inspection. So that's it, guys, as far as the double sampling plan is concerned, right? So thanks a lot for this